growth and decay functions, as well as using some different function operations with that. Okay. So in an exponential function, the independent variable is an exponent. So x is the exponent. It has the form f of x or y equals a times b to the x power. A is the initial amount. So once we get into word problems, that will be the starting amount. And it won't equal 0 because otherwise it'll eliminate everything. The base b is a constant, meaning a number, and the independent variable x is the exponent. So when you plug numbers in, those would be the different exponents. So for an exponential growth function, for growth, b has to be larger than 1. Okay. It can be any number, but b has to be larger than 1. Exponential growth occurs when an initial amount increases by the same percent over a certain period of time. Graphs of exponential functions have asymptotes. It would be a horizontal one. Okay. And then that would be the line the graph would approach but not touch. So we'll be identifying that to help us with domain range. And then end behavior we'll also be bringing in as well. Okay. So let's go ahead and graph it first. So I started the table for you. So we'll graph it, plot it, and then we'll answer these questions. So your function is right here, so 2 to the x power, so x is the exponent. So I'll go to y equals, if anything's there, clear it out. 2, again you can do the little exponent button right below clear, and then make sure x is there. Now all of these have a very specific shape. So if you do hit the graph button, on growth, it will start very, very low, almost look linear, and it will make a big spike. Now in your table, so I gave you the x values to use. Go ahead and write down those values. Now for negative 2.25, you could also write down as 1/4. It's the same thing. And 0.5 is 1/2. So you can write 0.25 or 1/4. That's totally up to you. And then go ahead and plot those. Whoops. 8 would have been 3. So plot those, and we'll talk about what's going on. You notice those first 3 kind of look linear, and this is when it's going to start curving. 1, 2, and 3, 4, and so on. Now this is not a parabola shape. It's going to be flat on one side and then spike up in one direction. Once we get into more graphs later next week, some of them might go down instead. They'll be reflected, but we'll get there eventually. Okay. All right. Now, based on the shape of the graph, it's overly continuous. It's going forever to the left and forever to the right. So what does that mean for the domain? All real numbers. Okay. Now, does it look like the y values are going to go up forever? How about down? No, they're stopping, okay, but they're definitely going down, but they are stopping at the x-axis. So that means there's an asymptote at the x-axis, which is y equals 0. Okay. So the horizontal axis. Now once we get into transformations next week, the asymptote will shift up or down. If there's something added on, it'll be like to the x power and then plus a 1 after it. Just like we just talked about with the square root functions. So for today, they should all be y equals 0. So that means the y values can be anything above 0. So it won't include 0 or negative. So you could be very simple with it and say all positive real numbers. Now that's actually how the book says it in your answers. So all positive real numbers. If you wanted to write either f of x or y is greater than 0, not equal to. Okay, just greater than 0, that should cover it. So all positive values, but not including 0. Okay. I would accept either one. Do we see a y-intercept? And 0, 1. Okay. It's wherever the x value is 0, that's the y-intercept. Okay, and there should be one always. All right, end behavior. Now, since we have an asymptote, that's going to limit the end behavior. As x approaches positive infinity, so it's going to the left, it's getting closer and closer to the x-axis. So we were used to doing positive infinity or negative infinity. It's going to be approaches 0 on that. So as x is going the negative direction to the left, the y values are approaching 0. But these decimals, so the further down the x values go, -3, -4, the decimals will just get smaller, but it will never quite hit 0. Okay, so if you scroll around in your xy table in your calculator, it's just going to get smaller and smaller decimals. Okay. Versus as x approaches positive infinity, meaning going to the right, that will be a positive infinity on that side. Okay. So these will have a limit on their end behavior. One of them will be the asymptote, okay, depending on which way it's going. The other one will be either positive infinity or negative infinity. So having the visual helps a little bit. You might be able to answer it without, okay, but having the visual helps. Questions on any part of that? Okay, assuming we're all understanding. Now decay would be, the graph would start high and go low. Okay, so it's just going to look like it's flipped around. All right, so a real life example of that is you buy a brand new car, drive it off the lot, it's dropping in value, and then it slowly flattens out. Okay, so a car depreciating. Obviously the cars at Barry Jackson, that does not apply to them. Okay, but on an average car, there's way too many side conversations going on right now. All right, now in the equation, because you're gonna have to be identifying growth and decay, the B value is between 0 and 1. Okay, so the previous one, it was larger than 1 for growth, which means it's doubling, tripling, quadrupling in size. This one will be decaying, all right, between 0 and 1. So a decimal or a fraction less than 1, but it will still be positive. So this would be decay because the base value of x is 1/2, and that's between 0 and 1. Okay, but it can be any fraction or decimal between 0 and 1. All right, so I want to remind you of something when we graph these in the calculator. So go back to your y equals and clear that out. That base is a fraction. Now, could you change it to 0.5? Yes, but that if that was a 1/3, what you're going to want to do, put parentheses, 1 divided by 2, close the parentheses, then raise it to the x power like that. Now, since 1/2 is a finite decimal, you could do 0.5 if you wanted to. Now, decay, it will be the opposite. It will start high and drop low to the other side. So it's just in reverse. Again, I started that table for you, so go ahead and fill those values in off of your calculator. Now, if you look at the table on the previous problem, you'll notice they're just reversed. Okay. So they're completely opposite. So the positive one on this one had a 1/2. The negative one had a 1/2. 0, 1's the same. -1, 2, +1, 2, -2, 4, +2, 4. So the reciprocal of 1/2, the points are just reversed in the y column. All right. Plot those. They have similar shape. Five points on these is pretty standard practice for your graphs. Okay. Now, some of you have a habit on your homework. You turn in graphs to me like this. I'm not giving you squat for that, because that doesn't tell me anything. Okay. So if you do that, you're not getting credit for those problems. Everybody clear? All right. A lot of you do that. All right. What's the domain? All real numbers. So there's no limit on the graph left to right. And yes, you can use that symbol. What's the range? It's all above the y-axis, so it's just all positive numbers. If you wanted to write that as y is greater than 0, that's fine. but all positive real numbers. I believe that's how the book is going to say in the answers for your homework. So if you wanted to keep it like that, that's fine. All right. So if the entirety of the graph is lying above the x-axis, that's what you can say. Y-intercept, 0, 1. What's the asymptote? Y equals 0, which is the x-axis. Okay. Again, that would only change if it was this function and then a plus or a minus a number after it, which we will do next week. And behavior. As x approaches negative infinity, so the left side of the graph, positive infinity. Okay. As x approaches positive infinity, where's the y values going? Towards 0. Okay. So for today, if it's decay, it should look like this automatically. If it's growth, it should be the reverse. So it goes to 0 on the left, positive infinity on the right. Those are the only two graphs we're doing because I don't feel the need to belabor the point. So is there any questions on those? So if you can identify these without a picture of a graph, great. But if you have to graph anyway, you can do it first, if that makes more sense to you. All right. Given the fact we just talked about growth and decay, you're going to determine whether each one of these would be growth or decay. What are you looking at to figure that out?
B.
The value of b, which is the base of where the exponent is. Okay. So in this case, it would be 0.7. Is 0.7 larger than 1 or between 0 and 1? So, since that is less than 1 but larger than 0, meaning it's positive but smaller than 1, that would be exponential decay. Now if you just wrote decay, that's fine. Okay. But that's why, is because it's between 0 and 1. Now there's two different numbers on B. Which one are you looking at? The one with the x as the exponent on it. The 1/2 is the a value. So on your, at the top of your paper, it's a times b to the x power. You're looking at the b value. So the one with the x attached to it. So just 3. Since 3 is larger than 1, that would be exponential growth. So if you had to explain, you'd say 3 is larger than 1. Okay. I don't know if you'll have to explain or not, but that would be your explanation. What about C?
I would say it's the growth because greater than 1.
So 4/3 is a fraction, but is it less than 1?
It's 1.
No. Okay. If you weren't sure, change to a decimal. That's 1.33333. That's still larger than 1. And the last one?
Decay.
That would be decay. So 1/5 is less than 1, but larger than 0. Alright. So it's all about the base of where the exponent is. Questions there? Alright. Now we're going to begin with some word problems, but we're going to get into more of those next week as well. So exponential growth and decay can be modeled by the function. Now this is a modification of the function we were still just using. Okay. So a times 1 plus r raised to the t power. Now that's in the same format as the one way down the front. A times b to the x power. B is just that quantity in there. T is the x. A is still that number out front. So it's the same format, it's just applied to word problems. A of t, or the f of x side, represents the amount after a certain time period, which is t. A is the initial amount, or the starting amount. R is the percent of increase or decrease over the time period. Now if it's growth, so you might have to read the problem to determine if it's growth or decay, it's 1 plus r. Now r is a percent, so you have to change the percent to a decimal. So maybe put a note on that. So R is the percent changed to a decimal. Okay. Do not put it in as its normal thing there. So what's 25% as a decimal? 0.25. So you move the decimal twice in front of it. 7%?
0 or 0.0.
0.07. So you have to change it first before you enter in there. Now decay, if you notice decay is going on, it's 1 minus that decimal percentage. So that's the only difference. Usually it's going to be growth, but you would just change that to a minus right there if it's decay. Okay. Alright, so I did mention that there too, but the percentage needs to be changed to a decimal before you can use it in the problem. Okay. So we're going to be using that in these two problems. So let's say you invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. That's actually very high compared to now. Now it's like a 0.05%, something like that. How much money will be in the account after 6 years? Okay. Now would this be a growth or a decay? Growth. It's increasing. Okay. Now this is provided you don't touch it, obviously. So we still have that formula at the top. Now the capital A part, that's the ending amount. That's what we don't know. Okay. Now we need to, what I want you to do, if this comes up in your homework, just list what these would be. So the lowercase a would be what?
That would be
1,000. That's your starting amount. 1,000 is going to go where the little a goes. Your rate.
0.0.
It's 5%, which is 0.05. So this is where you would have to change it. T would be how many years? 6. So normally I want you to copy down the original problem in your homework. If it's a word problem, I just want to see this, and then you plug it in the formula, because then I'll be able to figure out what's going on. Okay. Now once you plug it in and set it up correctly, then yes, the calculator will do the rest of it. Now it's 1 plus our percent. This is 6th power. Now what's 1 plus 0.05? 1.05. But could you enter it in the calculator exactly like this? Yes, because it will do the order of operations for you. Okay. So we're gonna go, if you need to get out of here, second mode to get back to your main screen. So 1,000 times either 1 plus 0.05, or you can do 1.05 and combine them, raised to the power of 6. Okay, exactly how we set it up on our paper. Now where do you round money?
The nearest second.
Okay, 2 decimal places. So that would be what?
1,340
And 10 cents. 40 and 10 cents. So after 6 years of the money just sitting there, you made $340. Okay, that's actually a very high percentage. Now you'd be lucky to get that. Okay. Obviously, if you put more money in there, would you get more because of the percentage? Yes. All right. But for just sitting there, you get an extra $340. So, not a bad idea. All right. But is everyone clear on how to set it up and evaluate? Now, if it was decay, if it was talking about a car depreciating, then we would put a minus sign in there. That's the only difference. Okay. All right. Yeah.
The minus sign with the plus sign is?
Yes. So then it would look like 0.95 because you subtract 5% from 1. All right. Now, it's the same information. So you've invested $1,000. So that's your A, lowercase a value, with an annual interest rate of 5%. So that's your R. How many years would it take to reach $1,500? So we don't know T. Okay. Now, could you put $1,500 where the A of T is and do that? Yes, but we actually haven't learned how to do that yet to solve for what an exponent would be. That's coming this unit. So, still set this up. Now, yes, we would want around 1500 over here, but we're going to use the calculator graphing portion to do this part. So we don't know what t is. Alright. So if you were given an ending amount and asked to figure out what would the exponent be to get it there, for now, you're going to use the graphing portion of that, not the physical graph, but the XY table to do this. So we're gonna plug this into y equals, so this would be where your y equals is. Instead of t, you would put an x up here. And then we're gonna pull up our table. Alright, so you can do 1000 times 1.05 raised to the x power. Use parentheses. Okay, so in your y equals, so instead of t, you just change it to the x. Okay, but time is independent anyway. All right. Now you don't need the actual picture of the graph. You probably actually won't be able to see it very much, okay, because it's such a big starting amount. So you can go straight to your table. What happened? There it went. So it is asking us about how many years, which is a certain number of x values, until you reach 1500 bucks. So where do you think you're looking? So scroll until you see 1500 in the y column. Now it may not be exact. Okay, there's a lot of decimals. So it first hits over 1500 at 9. So you would say approximately 9 years. Okay. Now, would that be exact? No, but that's when you jump from 8 to 9 years. It's only annual interest, so that's the percent is only applied once. So it's not going to be 8 years and a certain number of months. That percentage only hits once a year. So it will jump past 1500. So approximately 9 years. Okay. Now, eventually, we will learn how to. We would put 1500 here. We would do some different things to get the x out of the exponent, but we will do that eventually coming up in this unit. But you can use that XY table in order to figure that out. Okay. Now that's all we're starting with today. We will have notes on the day 2 as well. I just wanted you guys to get used to this before we bring in more stuff. Okay. So any questions before you